Lesson 1-8, solving equations using inverse operations. Objective of this lesson, to use inverse operations to solve equations and to solve problems using equations. Let's consider this example. Transportation. When the New York City subway service began in 1904, passengers bought tickets from the attendant for 5 cents. Another attendant tore the ticket as you passed through the turnstile. Soon the turnstiles were made to operate on coins. When the subway fare was changed to a dime in 1948, turnstiles could still operate on a coin. However, when the fare went 15 cents in July 1953, there was a problem. That's when the New York City subway token was introduced. The bullseye tokens in New York subways today have brass surrounding a steel center. Since the turnstiles read tokens with a magnet, using bullseye tokens helps reduce the use of slugs, which are worthless pieces of metal used instead of tokens. Before the bullseyes, New York took in about 165,000 slugs each month. Now slugs total about 20,000 a month. In 1995, New York subways lost about $25,000 a month to people using slugs. Okay, what was the subway fare in 1995? Okay, so knowing this information, okay, we will be able to solve this problem, and we will be able to answer what was the subway fare in 1995. Okay, if you did not follow what I just read, you can always go into your book on page 41, or you can just rewind this video. We will solve this example. We will solve this problem in example 3. Let's learn the concept for now. Concept is, you have solved some equations using mental math or patterns, but sometimes the solution is not easy to see. Another way to solve equations is to use inverse operations. Inverse operations undo each other. Remember the word undo, because once we start solving equations, I'll be using that word a lot. Inverse operations undo each other. For example, to undo addition, you would subtract. So the opposite operation of addition would be subtraction. This can be shown by related sentences. The sentences below show how addition and subtraction are related. 9 plus 12 equals 21. Well, you can also say that this is 9 equals 21 minus 12. Or another way of saying that would be 12 equals 21 minus 9. So they basically undo each other, but they are also basically the same sentence. They're very related to each other. Okay? Another good example, if you have, instead of all numbers now, let's put in a variable. What if we have 9 plus n equals 18? So following the same principle, that would be 9 equals 18 minus n, or n equals 18 minus 9. Okay, so you have addition, and the inverse operation would be subtraction. Okay? Take a look at the next example, or the next operation, which is multiplication. And in multiplication, okay, and division, there are also inverse operations. Let's look at multiplication first. 3 times 5 equals 15. If you look at the inverse operation of 3 times 5 equals 15, okay, we can say that 3 is equal to 15 divided by 5, or 3 equals 15 over 5. Remember, the fraction bar also indicates the operation of division. Okay? Another way of saying that, using inverse operations, would be 5 equals 15 divided by 3, or 5 equals 15 over 3. Okay? Now let's throw in a variable. Let's say we have 12t equals 48. Remember, 12t represents 12 times t, so that this is a multiplication operation. If we want to use inverse operations, this becomes now 12 equals 48 divided by t. Okay, or 12 equals 48 over t. Or we can also say that t equals 48 divided by 12, or 48 over 12. Okay, so these are inverse operations. Now, knowing this for addition and multiplication and division, you can use inverse operations to solve equations. Take a look at these examples. In example 1, you have b minus 6 equals 42. Okay, and b minus 6 equals 42. If we do inverse operation, remember b minus 6 equals 42. Using inverse operations, we can do b equals 42 plus 6. Okay, we write a related addition sentence because this is subtraction, and in order to undo it, we need to use the opposite operation. Okay, and then if we simplify this, this now becomes b equals 48. So the value of b in this case would be 48. The letter b, in the same manner, we can write c plus 16 equals 54. We can do c equals 54 minus 16, write a related subtraction sentence, and we simply simplify 54 minus 16, which is 38. And you can check your answer, of course, by replacing 38 in the original equation, or simply getting this, putting it back there, and see if 38 plus 16 is equal to 54. And we've checked our answer. In letter C, it's a division equation. V over 9 equals 16. So remember, the inverse operation of division is multiplication, so this becomes V equals 16 times 9, or V equals 144. In letter D, it's a multiplication equation, so the inverse operation is division. So this becomes S equals 37.5 divided by 2.5, the related division sentence, or S equals 15. Okay? That is example number 1. Again, using an equation to solve a problem is an important problem-solving strategy. The first step in any equation is to choose a variable, any quantity, for a variable to represent. This is called defining a variable. So when you're talking about a word problem, this is the first step, defining a variable. And when you define a variable, we always start it with a let statement. Okay? So let statement will be the very first thing that you need to do in any word problem. Let's take a look at example number 2. The sum of 215 and a certain number is equal to 266. Find the number. First, identify what the problem is asking for. In this particular word problem, it's asking you to find the number. Therefore, we are trying to look for a number. So, we define the variable according to what the problem is asking for. Let n represent the number. Again, that's why it's called the let statement, because it starts with the word let. Now that you have the variable, translate the words into an equation using the variable. So if n is our number, let's go back to the problem. The sum of 215 and a certain number is equal to 266. Okay, so now this becomes 215, okay, and a certain number plus n equals 266. You end up with 215 plus n equals 266. And using inverse operations, we can find the value of n to become 266 minus 15. We wrote a related subtraction sentence from the addition sentence, and the value of n is 51. So the number is 51. If we want to check our answer, okay, we simply get 51 substituted back to n. We end up with 266, which is the correct answer. Okay? And finally, going back to our example, okay? So again, using our 4-step plan to solve the problem at the beginning of the lesson, if you still recall the problem at the beginning of the lesson, it is asking for what was the subway fare in 1995, okay? So read the problem for a general idea. You know about 20,000 slugs are used each month for a loss of $25,000. You need to find the subway fare. each slug is equal to 1 fare, so let F represent the fare. So again, in any word problem, let me repeat that again. You need a let statement, or you need to define what the variable. So in this case, we let F represent the fare. In our 4-step plan, we try to find a way to solve this problem. We plan a way, translate the words into an equation using the variable. The total amount of money lost to people using slugs is the number of slugs multiplied by that fare. So how do we go about doing that? Okay, we do this. We let F represent the fare, okay, and multiply it by the number of slugs, which is 20,000, should equal, okay, 25,000, which is the total amount lost. Okay, and if we solve this using inverse operations, that would be using inverse operations, that would be 25,000 divided by 20,000, and the result using a calculator, okay, would be $1.25. Okay, answer is close to the estimates. Is 20,000 times 125 equals 25,000. The answer checks out. So the fare is $1.25. Okay. And the lesson again, boys and girls, on Google Forms, type a summary of what you've learned responding to the objective of the lesson, and type a question you might want to ask in class. Thank you.